Hi all, I'm Vinay Kumar. In the series of ARM-CORTEX M4, today I will explain you what are system exception control registers. In my previous video, I already explained you what are the different types of system level exceptions in ARM-CORTEX M4. Today I will explain you what are the system control registers. I mean system exception control registers, which are used to control the system level exceptions and configure the system level exceptions and also check the status of system level exceptions. For that, first, we should know what is the system control block. The system control block is one of the peripheral of ARM Cortex MX processor. Here, see, the system control block, that is SCB, provides system implementation information and system control. This includes configuration, control, and reporting of the system exceptions. The system control block registers are, I will show you that registers also. Here, the main functionality or the main thing of system control block is it have a set of registers for system exceptions. By using that registers, we can control the system level exceptions. Okay, first let's see what are the different peripherals of ARM Cortex MX processor. There are many peripherals. A few among them are NVIC, FPU, MPU, SCB, and System Timer Debug Unit. Here, we are going to look into this SCB, that is a System Control Block. Here, all the registers of these peripherals are mentioned in PPB block. Remember, PPB is nothing but private peripheral block. Actually, this block contains all the registers of system specific blocks that are nothing but system specific peripherals. Those are NVIC, MPU, SCB, System Timer. All these registers are present in this PPB, that is private peripheral block, and you can access or you can read write these registers by using one bus, that is PPB bus, that is private peripheral bus. Here I will show you that thing. Here see, this is the ARM Cortex MX processor, and here see, this is the PPB bus, not a PPB bus, it is a PPB block, that is nothing but private peripheral block. In this block, you'll have all the registers of system specific peripherals. System specific peripheral are nothing but NVIC, SCB, MPU, debug, all that registers are present within this PPB block. And then, okay, here I'll show you what are the different types of system exception control registers. Okay, okay. Here, see, there are, right. First, let me move to peripheral bus. Yes. Here are some of the registers of private peripheral bus. Here, see, there are many registers which comes under the private peripheral bus. Here, see, every register address starts with E0. Here, observe, all registers under private peripheral bus starts with E0. And remember one thing, whenever a register address starts with E0, then you can easily say that register comes under system private peripheral bus registers. And by using these registers, you can configure the system level exceptions or as well as system level things. Okay, now we are going to see the system control block, that is right here. I'm clicking this one, and these are the some of the registers of system control block. Here are the many registers for configuring the system level exceptions. No need to look all these registers. Here are some important registers. Here, see, system handler priority registers. Here are the 4 system handler priority registers. By using these particular 4 registers, we can give priority for our system level exceptions. So, here I will show you what are our system level exceptions. Let me maximize this one. Yes. Here, see, these are 9 system level exceptions. Those are hard fault, NMI, usage fault, mem manage fault, bus fault, cystic exception, SVC exception, pendusty exception, and debug monitor exception. These are 9 different system level exceptions. In general, we have 15 system exception, but in 15 system exceptions, 6 are already reserved. So now we have only 9 system exception. See here, This hard fault and NMI are always enabled. We can't mask these two exceptions, but this usage fault, memmanage fault, bus fault, and Pandasvi debug monitor exceptions, these particular exceptions we can mask. By default, these are disabled only. Okay, and these are the different types of system exceptions, and I will show you now system exception related registers. Okay, these are the some of the registers of system control block. Here see, by using these four registers, those are system handler priority register 1, system handler priority register 2, 3, 4. You can configure the system level exception prioritizing. Okay, now let me open this fourth one, that is system handler control and status register. It's one of the important register. Here see, this is the system handler control and status register. Here, what is the use of this register? It's one of the status register. Here observe, whenever the 0th bit of this particular register is set, then you can say the particular mem manage fault is active. Okay, when the 0th bit of system handler control and status register is 1, then you can say mem manage fault is inactive. When the first bit of system handler control and state register is active, then you can say the bus fault is inactive. And this second bit, and its second bit is reserved. And coming to the third bit, that is if the third bit is active, then you can say the usage fault is in active state. And here are the 19 bits are using, and the remaining bits are reserved in the system handler and control register. And by using these 19 bits, you can check the status of every register. Okay, not every register, every fault. Okay, and for every system level fault, there is corresponding bit. If that bit is set, you can say that particular exception is in active. And now see, okay, these are the some of the peripherals, and let me open that peripheral bus and the system control block. And see here, there are few more registers. Those are uh, bus fault status register, usage fault status register, hot fault status register, mem manage fault status register, and these are the some of the register which are specifically used for these faults. Here see, the first one is, that is the bus fault status register. This particular register is used to show the status of bus fault. And the second one is usage fault status register. It is used to show the status of usage fault, and so on. And these are some of the system level exception control register. By configuring these register with the um, recommended values, you can configure your system level exceptions. Remember, hard fault exception and NMI exceptions are highest priority level exceptions. You can't configure their priority, and you can't mask them also. And remaining are all configurable priorities only. You can mask them also, and by using these particular registers, you can uh, do whatever you want. You can prioritize your interrupts, or you can mask your interrupts. Okay, and these are all about system exception control register. I hope you understand this class. If you have any further doubts, let me know in the comment section, or I will give you my Instagram channel, Telegram channel, and my personal mail ID in description box. You can go and you can ask me your doubts. Thank you for watching this video.